Kia ora everyone, this is almost everything you'll need to know about the hand. The hand is a bit complicated. There are lots of small muscles in the hand, as we can see from this table in your book, but we can break them down, and just knowing a few key facts about the groups of muscles can help us put them all together. The first group of muscles are the interossei. That means literally between the bones, and these muscles are found in between the metacarpal bones. And there are two groups. The deepest group are the dorsal interossei, then a layer just anterior to that are the palmar interossei. Most people recall that the dorsal interossei abduct because they remember dab, and they recall that the palmar interossei adduct the fingers because they recall pad. And we can use that in a few other facts to work out where they are and how they function. So the key to this is to remember that there are 4 dorsal interossei. So if you draw a 4 and then turn it into the dorsal fin of a shark, because what else would you do? Then you'll realize that sharks, as well as the dorsal fin, also have 2 pectoral fins and an anal fin, which we won't need to use. But with its 2 pectoral fins, it can hold pens. So we'll give it a blue pen here and a red pen so it can mark your homework. So a shark can hold 2 pens, and the 4 dorsal interossei are bipinnate, which means that there's a central tendon and muscle fibers either side. So many muscles are bipinnate, but some muscles such as flexor pollicis longus are unipinnate, and we'll see some of those shortly. But the point is to remember there are 4 dorsal interossei. They are bipinnate and they abduct. This is in distinction to the palmar interossei. We'll draw a palm tree. It has 3 big leaves because there are 3 palmar interossei, and 3 is the maximum number of leaves we can be bothered drawing. And we can give it a pen, but it doesn't have any prehensile limbs, unlike our friend the shark, maybe. So you give it a pen and it just falls on the sand. So you don't give it another one. So therefore it's unipinnate. That means it has a tendon, but muscle fibers only come from one side. So there are 3 palmar interossei, and they're unipinnate, and of course they adduct. So the point of these drawings is that they're so stupid that you can't forget that now, hopefully. And when we return to our hand, we can add in the 4 dorsal interossei, and we know they're bipinnate, so they attach with a central tendon to each side of adjacent metacarpal bones. And because we know that they abduct, they move the fingers away from the center line, and most of these small muscles will attach here to the base of the proximal phalanx or phalanges. This is the hot spot for the small muscles of the hand. So in order to make them abduct, we attach them like this so that the ring finger abducts. The middle finger abducts both ways. It doesn't adduct, it only has abductors, and the index finger can now abduct this way. That leaves our palmar interossei to adduct. We know there are 3 of them, and they're unipinnate. So we'll have one for the little finger, and they also attach to the base of the proximal phalanx. So it comes off the metacarpal of the little finger and attaches to the base of the proximal phalanx. Same for the ring finger. The third finger, the long finger or middle finger, doesn't need one because it only abducts either way. So we only need one now for the index finger. So now these fingers can all adduct. We see that the thumb doesn't have an interosseous adductor because there are only 3. Instead, it has its own very large muscle, which is adductor pollicis. It arises by 2 heads, one from the shaft of the 3rd metacarpal and the other from the capitate bone here, and they extend via the sesamoid bone to the base of the proximal phalanx of the thumb. The shape of the muscle is somewhat reminiscent of the sails of a boat, so you can go back and draw a boat along with the shark and the palm tree if you fancy. So that's adductor pollicis. So now the thumb also can adduct. So we see that the thumb hasn't yet got an abductor, not a small one, and neither has the little finger because there are no interosseous spaces left, so they need their own special muscles, and these are contained within the thenar and the hypothenar eminences or groups of muscles. And the thenar and hypothenar muscles are mirror images of each other. They have a common-ish origin or proximal attachment along these ridges that project out to form the walls of the carpal tunnel of the trapezium and scaphoid, and also the hook of the hamate and pisiform on the ulnar side, and also from the flexor retinaculum that bridges those prominences. There are 3 muscles in each group. The deepest is opponens, so it's a muscle that's fairly broad and flat and stretches from our common origin point here to wrap itself around the metacarpal shaft. And opposition involves a sort of pivoting motion of the metacarpal. So there's one from the hypothenar as well. There's a degree of pivoting movement available at the carpometacarpal joint of the little finger, believe it or not. And so there's the opponens pollicis and opponens digiti minimi. More centrally placed in each eminence is a short flexor. So from our common proximal attachment, we have a flexor pollicis brevis. This time it does attach again via this other sesamoid bone to the base of the proximal phalanx. It has 2 heads, flexor pollicis brevis, a deep head here, a superficial head, and in between them what separates the two is the tendon of flexor pollicis longus. It has come from the forearm. Flexor pollicis brevis, and same story for the little finger, flexor digiti minimi. Some people say brevis. There's no flexor digiti minimi longus, but there are 2 other flexors. There are 2 long flexors of the small finger, flexor digitorum profundus and flexor digitorum superficialis, the most ulnar tendon of each. The little finger gets a 3rd flexor, which is very strong because the little finger is a key component of a strong grip. It's very hard to grip something with power without using your little finger. Finally, we have our abductor for the thumb. This is abductor pollicis brevis. Abductor pollicis longus was in the forearm, and it overlies opponens and is the most radial of the thumb thenar muscles, again attaching to the base of the proximal phalanx, often sharing that sesamoid bone. So that's abductor pollicis brevis, and the matching muscle on the hypothenar side, abductor digiti minimi. Now, abduction is possible of all the digits. Yikes. Lastly, we have the lumbricals or lumbrical muscles. These are worm-like in appearance and extend from the tendons of flexor digitorum profundus proximally to the extensor expansions posteriorly on each of the 4 fingers. The ulnar 2 are bipinnate and come off adjacent tendons and extend backwards, and the radial 2 are unipinnate, so arising from just one tendon. I won't draw in the extensor expansions because it'll get too messy. So they don't attach to bone anywhere, and their function is to flex at the metacarpophalangeal joint while extending at the interphalangeal joints, the so-called Z movement. In fact, the palmar and dorsal interosseous muscles also have small slips of attachment into the extensor expansions of each finger, and they also therefore contribute to this Z movement when they contract together. So palmar and dorsal interossei and lumbricals all contracting together will tend to cause flexion at the metacarpophalangeal joint and extension at the interphalangeal joints, and therefore they provide a strong basis for hand grip. I'll add in the tendons of flexor digitorum superficialis just for completeness. There are synovial sheaths and overlying aponeuroses, which I won't draw, but then we will have a look at some tidier diagrams now just to review. So here's a superficial dissection of the hand. We see the palmar aponeurosis, which is continuous with the tendon of palmaris longus here, and this is palmaris brevis, this very thin sheet of muscle. If we remove those superficial structures, we can see the hypothenar group of muscles here and the thenar group here, along with the long tendons passing underneath the flexor retinaculum If we remove the tendons of flexor digitorum superficialis, we can see the lumbrical muscles attached to the tendons of flexor digitorum profundus, the ulnar two lumbricals being bipinnate, and the radial two being unipinnate. Removing those structures, we can see more clearly the thenar and hypothenar muscles, or some of them. This is the transverse head of adductor pollicis, and this is the oblique head. Attaching to the medial ulnar side of the base of the proximal phalanx of the thumb. We can also see adductor pollicis brevis here, superficially and most radially, and adductor digiti minimi here. Removing the two abductors, we see flexor pollicis brevis. There were two heads there, separated by the tendon of flexor pollicis longus. Here is flexor digiti minimi brevis. That was partially hidden by the abductor, and we can see opponens pollicis here, this flatter sheet of muscle wrapping around the metacarpal shaft. We can also see the palmar interossei, which will be adducting the unipinnate muscles. They will send a little sliver of attachment out to the extensor expansions of each digit as well. And finally, removing those muscles, we can see abductor digiti minimi here and the bipinnate dorsal interossei, the deepest layer. Again, also sending slivers of attachment to the extensor expansions. Finally, now going back to the table just to try and make sense of it. We see the thenar group here, or the three with the common proximal attachment, opponens attaching to the lateral side of the first metacarpal and the other two attaching to the lateral side of the base of the proximal phalanx. Adductor pollicis here, the sail-shaped muscle with two heads. From its attachment more centrally, the third metacarpal and capitate bones essentially, and the medial side of the base of the proximal phalanx of the thumb is its distal attachment. Of the hypothenar muscles, essentially a common proximal attachment here, and again the opponens attaching to the side of the metacarpal, while the other two, flexor and abductor, attach to the base of the proximal phalanx. The dorsal interossei from adjacent sides of the metacarpals as bipinnate muscles, attaching to the, again, bases of the proximal phalanges and the extensor expansions. The palmar interossei unipinnate muscles, and again attaching to the base of the proximal phalanx and extensor expansions. Finally, the lumbricals from the tendons of flexor digitorum profundus, either unipinnate or bipinnate, and to the lateral sides of the extensor expansion, so running from a tendon to a tendon. Alright, that's almost everything you need to know about the hand. We'll cover all this neurological stuff in a wrap-up of the upper limb in the next video. But until then, enjoy the rest of your day. Ka kite.